of the things that I want to tell you about in this particular problem for number 5 is that when you deal with fractional exponents, you kind of need to understand what's going on with those fractional exponents. And so fractional exponents work like this. If I were to see something like x to the 2/3 power, and there's just one thing, what that's saying is that you have the cube root of x squared. Or in other words, the top thing, that is your exponent, or your power, and the bottom thing, that is your root. And the reason I'm telling you that is because in this particular problem, I'm actually going to show you a couple of different ways to solve this one. I like a particular way, but there's 2 ways that I think are really good. This particular problem is saying the following. It's saying that I actually have x plus 3 being squared, and then I'm taking the cube root of that, and that's equal to 4. Now this problem is kind of messy when you look at it that way, but the first thing that I have to get rid of is the cube root on the outside. And then to undo a cube root, we're going to cube it. So I take this side, and I cube it, and I take this side, and I cube it. And the cubing and the cube rooting, since they're inverses, cancel each other out. That leaves me with x plus 3 squared equals 64. And now I need to undo the square. So I'm going to square root. So I square root both sides. Uh-oh. I square rooted a variable.
That means it's positive. There's 2 solutions.
2 solutions. Very good. So I have x plus 3 equals plus or minus 8. And then if you move the 3 to the other side, you get x equals negative 3 plus or minus 8, which means that your x could be negative 3 plus 8, which is 5, or negative 3 minus 8, which is negative 11. Now, if you're checking your work, you can plug those numbers in later and see whether or not they both work. Make sure you check them. Okay, so negative 11 and 5. Actually, I'm just going to do one weight for right now because we have a short day today. There's a way to work with fractional exponents where you just raise it to the reciprocal exponent and it takes care of it, but I like this way better. Sorry, any questions? All right, last problem. We've already seen this problem, except there's one thing that's different. 2 roots. That means we're going to have double the fun. What was the strategy when you see a root problem?
Square.
Isolate the radical first, and then square. The problem is we have 2 roots. So we pick one of them to isolate, square, and see what happens. Okay? Here we go. I like to get the one that's the most complicated by itself, because I can get rid of that one first. So I'm going to isolate the 2x minus 5 one to start with. And if I do that, I get the square root of 2x minus 5 equals 1 plus the square root of x minus 3. Questions so far? What next?
Square.
Square. So I square both sides. Great news on the left-hand side. On the left-hand side, the radical and the square cancel each other out because they're inverses, and you just end up with 2x minus 5. On the previous problem like this, when we squared the right-hand side, I used something called the Joachim rule. You guys remember that?
Yes.
Okay, I'm going to do it right now. Don't blink. Here it comes. Put your pencils down, pens, colored pencils, whatever you got, and watch. First thing, what should I do? Square it. That's a 1. 1 squared is 1. The second thing is a square root, and I'm going to square it. When I square square root, cancels out. So I just get x minus 3. And the last step is to multiply everything you see. So 2 times 1 is 2. And 2 times the square root is 2 square roots of x minus 3's. Okay, now write. Now if you don't want to do it that way, have fun foiling. Square the first thing, square the last thing, multiply everything together. Works for all squares. And some of you rectangles.
Wait, look. The only thing on the right side is to.
Square the left, square the right,
Oh, right. Yeah.
multiply everything together. So if I were to multiply everything together, just to kind of give you a visual, this is everything multiplied together, and this is what it produced.
Oh.
Good? That is the hardest thing in this problem. Right there, my opinion. Brutal. But if you get that Joachim thing, it's going to be super easy. Okay? Still have a radical. So I'm going to keep the radical, the stuff in the yellow highlight, on the right-hand side. I'll move all the other junk to the left. So if I move the x thing to the left, I have 2x over there, but I'm going to take away 1x, so now I've got 1x left over. I had a 1 and a negative 3 on the right-hand side. That really produces a negative 2 on the right. So when I take that negative 2 value and I move it to the left, it becomes positive 2. So I really have minus 3 now on the left-hand side. And on the right-hand side, if I leave the radical with its 2 attached, it's like this. In essence, I was adding and subtracting terms to make the radical be by itself. By the way, I am going to pass back tests tomorrow, no matter who's done and who's not done. Okay, so now we got the radical thing, the radical term by itself on the right, everything else on the left. I'm going to square both sides. So now the Joachim rule applies on the left-hand side. 1x squared is 1x squared. Negative 3 squared is positive 9. And 2 times 1x is 2x. 2x times negative 3 is negative 6x. So the left-hand side is that stuff squared. Yes, ma'am?
When exactly do we know when to use the Joachim?
Whenever you have a squared thing.
But the other side is also squared?
I'm not done yet.
Oh.
So I should say, excuse me, when you have a binomial squared, meaning two terms, something separated by plus or minus, and squared. Yes, sir.
Why didn't we get rid of the 2 in front of the radical?
I've taught this problem probably about 12 times, and what ends up happening is if I get rid of the 2, which is the way I taught it the very first time I taught it, there's a fraction on the left-hand side because I have something over 2. And then when you square that, that kind of messes people up because then you have to multiply back through by the 4 that's produced when you square the 2, and then now you're dealing with fractions, and so I just don't like it, and so I don't teach it that way anymore. On the right-hand side, if I square the 2, I get 4. If I square the square root, the stuff cancels each other out, and I just get the x minus 3. But that 4 is being multiplied by that radical, so now that 4 is being multiplied by all of the x and the minus 3. I'm just gonna simplify the right-hand side just a little bit here, so I got x squared, I'm leaving off the 1, minus 6x plus 9 equals 4x minus 12 when I distribute the 4. Because remember, the 4 is affecting the whole radical, which when it got squared was x and the minus 3, both. Now I'll get everything onto one side, because we want the quadratic equal to 0. So the x squared is already here. If I move the 4x to the left, it becomes negative 4x for a total of negative 10x. If I move the negative 12 to the left-hand side, it becomes positive 12 for a total of positive 21. I can set that equal to 0. If I'm fortunate enough, that stuff will factor. And
-3, -7.
thank you. X minus 3, x minus 7. Looks like it works. I like that. Which then, of course, means as I solve this, the x minus 3 equals 0, or the x minus 7 equals 0, meaning that we have solutions of 3 and 7. Again, make sure you check it to see if they work.